This is a video about lens diagrams, concave and convex lenses with answers. If you follow the link to the test shop, you'll find PDFs of the diagrams and of the answers as well, so you can try them yourself. If you follow the YouTube link, you'll find talk through versions of PowerPoints, as well as many other videos of equations, questions and answers. So the basics: light rays parallel to the principal axis are refracted through the principal focus for a convex lens. So to complete the diagram, we need to draw those lines through the focal point F, and they go through like so. So the one at top, that's parallel to principal axis, goes through like so, and remember to put an arrow on the end. The one at the bottom will go through like so. Again, remember to make sure you put an arrow on, and the one through the middle will just carry straight on through the focal point. Okay, so there's your first diagram. Now it's important to note as well that when you find these lenses in textbooks, they may not have the full shape. They may well just have a triangle which denotes the start of the shape of the lens, and then a straight line between them. So they would be drawn in the textbook like so. If you want to have a look at the proper version of that answer, there we go. Again, just remember that the lines, the rays, go through the focal point F. Now, let's have a look at the next type of lens. This is a concave lens. It caves inwards, like the entrance to a cave. For this lens, the diagram is slightly different. To denote that it goes inwards, the triangle is the opposite way round on diagrams. So the triangle looks like so on a diagram, but again, it's just a straight line between the 2 points of the triangle, which denote the action point of the lens. So parallel rays of light appear to have come from the principal focus. So they appear to have come from this point. So they'll be refracted away from that point. So let's just draw one in to start with, going from that point. Now to start, the line on that side of the lens that the ray came from is imaginary. It doesn't really exist. That's why it is dashed. If we were viewing from this angle here, we'd imagine that the ray came from that focal point. We would follow the ray back as if it came from there. Same's true for the ray on the opposite side of the lens. It would appear to have come from that focal point. So that's dashed, and then a full line from the end of the lens there. Okay, so that's how you draw those. A bit more accurate diagram on the paper in front of you now, or on the screen rather, in front of you now. Let's have a closer look then at different objects and introduce a second rule. So here you can see the object. The object is between F and the lens. We follow the rules again for drawing the rays of light. The one going through the centre of the lens, though, now with our new rule, will go straight on. So I'm just going to look at the top of the lens as the point that I'm going to think about. So it goes from there through the centre and goes straight on. Now I'm going to dash it on the other side because I already know that for an object between F and the lens, we won't be able to focus it. So here's the next one, and this goes through F. Parallel rays of light go through the focal point. So I'm going to draw that one like so. And you'll notice now that these two rays are actually divergent, which is why I have to follow them back again to imagine where the light came from. Remember, if your eye was down here, your brain wouldn't compute that the ray of light had been bent at this point. Instead, you'd just imagine it further back. Where the two lines cross, we can draw our image, like so. And the image has some features that you need to know about. It's magnified, it's bigger, the height of the image is bigger than the height of the object. So when we work out the magnification, the answer will be greater than 1. Okay, that's a quick check. It's virtual. We couldn't put a screen at this point here and focus an image onto it. It's a virtual image. It's the right way up, and it's outside 2F. There's 2F and it's outside 2F. Let's have a look now at a proper diagram accurately drawn for that image. And you'll see 4.2 is the magnification that I got. As long as you get an answer within 10% of that, it should be okay. Outside 2F, the right way up, magnified and virtual. So a use of this would be in a magnifying glass. Okay, so the next one then. This one is for an object between F and 2F, and the rules we follow are the same. So I'm going to do them in order this time. So the parallel ray will go through the focal point. Try and draw this as accurately as possible. It's not that easy on a screen. Make sure there's an arrow. The one through the centre of the lens will go straight on, unrefracted. So I'm going to take that through there, unrefracted. And this time you'll notice that they cross. And where they cross, we can now draw our image. And you'll notice a few things about the image this time. And the things you should notice are the image is inverted. It's upside down. It's also magnified. It's bigger than the object. So this, again, will be greater than 1. It's also real, which means I could put a screen somewhere and I could focus the image onto the screen. Let's have a look at a more accurate version of that drawing then. And here we have the more accurate version of the drawing. And as you can see, the number or the magnification is greater than 1. Opposite side of the lens, it's real, it's inverted, it's magnified. And the use of these is projectors. Okay, so the next lens then. So we've done inside F, between F and 2F. Now we have one outside 2F. Take the first bit first. Parallel goes through the focal point. And the one going through the centre of the lens goes straight on. And we'll notice that again the real rays cross. So if a real ray crosses, we have a real image, an image that can be focused onto a screen. But you'll notice some of the things about our image. Again, it's inverted. This time it's smaller, so the magnification this time should be less than 1. Real, inverted and smaller. Where might this be used? Well, it's used in a camera. So the image is real, diminished, it means it's smaller, inverted, and its uses in cameras. That includes your phone camera. So those are our 3 images formed from convex lenses. Now let's have a look at a concave lens. And first of all, we're going to do the same thing as we did before. We're going to look at an object between F and the lens. So we'll do our first rule and then we'll do our second rule. So for our first rule, a ray parallel to the principal axis will appear to have come from the focal point down there. So I need to construct my line away from that focal point, remembering that part is imaginary and that part is real. So that's solid for the real ray, dashed for the imaginary part. A ray going through the centre of the lens will continue straight on, like so. And where the two cross is where the image is. So there is the image. You should notice a few things about the image. It's imaginary, as in we couldn't put a screen there because we have a construction line that it's made from. It's reduced in size, diminished, so its magnification will be less than 1. It's on the same side of the lens as the object. And let's have a look now at the real diagram. So there's the diagram as it should look, and the magnification of 0.6. Next one. So now we have between F and 2F. I'm going to include all these diagrams because of completeness, as if it comes from F. So there's F. We're going to draw the line as if it comes from there. Dashed for the start of it, and then real for the end. And the one goes through the centre, goes straight on. Just draw it in, like so. And there we have our image, and we can see that again, its magnification is going to be less than 1, but it's going to have the same features as the other one. Virtual, diminished, right way up, and between F and the lens on the same side of the object. Next one. We're going to carry on here. We're going to just draw them quickly. Parallel to the principal axis will appear to have come from the focal point. So I'm just going to dash that one in quickly. And then the one through the centre of the lens will just go straight on. And I think you're getting the picture that again we're going to be able to draw the image in. It's diminished, it's on the same size of the lens, and the magnification is going to be less than 1. Okay, so those are the ray diagrams for concave and convex lenses. You'll find further resources in the test shop and a YouTube link there where you can find more PowerPoints on other videos about equations, questions and answers. Don't forget to press like at the bottom if you've found this useful.